terms of bandwidth and you know, you mentioned latency, Clint, about coast-to-coast latency. How important do you see that as being, you know, the kind of the backbone for the infrastructure and the types of cloud solutions that people expect to happen?
You know, it's interesting. So you were talking about mobility and what's changed in those users. So we've gone from providing T1s to that service sector to now putting 100 gig links up between MSCs. So, and that's all because, you know, my 4 children have iPads and iPhones, and I do, and my wife and everybody else. So and they all expect, nobody cares about the cloud, and nobody thinks about it, or the fiber, until that app doesn't work, right, or doesn't download fast, or why did the song take so long, or, you know, so without the access, without the network, I think a lot of people overlook what that means to the cloud. Without the network, the cloud doesn't work. I mean, it just fundamentally doesn't work. Trading doesn't work. The financial services, you know, we did a build to Chicago, and the only reason we won that revenue was because we were fastest. Second place got no revenue. So latency is absolutely critical, and then, you know, scale of bandwidth is critical for certain sectors like healthcare, but you know, certain things are not possible over 50 milliseconds of latency, and certain things are. So that's why it's so important to try to get the hop to Europe as fast as you can, because it allows for perhaps backup, or the hop across the country. If you can get that down to 50 milliseconds, you can do storage replication in real time, and so you can have things start to work in more and more interesting ways if A, the network is fast, and B, if it's resilient, right, and diverse. Right. So it's important that Zayo's in a particular location, and it's important that I'm there going out, you know, the other side, because if we both go down, that provides a horrible, you know, experience to the customer, and you know, so I just see us going from, you know, the latency and all the increases that we're doing, or the decreases. It's amazing what it opens up, and what, you know, the expectations of the users become, and we're just going to see more and more and more of that.
Mm-hmm. And enables applications, basically.
That's right.
It's really the enabler. Do you want to add anything to that?
Yeah,
David?
I think it also enables, you know, the kind of more geographic diversity. You know, the big cost in data centers is power, or real estate, and, you know, the kind of the outsourcing to the cloud. Probably not fully, because there's still a lot of kind of server huggers out there that want to be close to their servers and their applications, to their data centers, even when they've outsourced it to the cloud. But, you know, areas like Wenatchee, Washington, you know, Cheyenne, Colorado Springs, area in the Carolinas where there's cheap power, there's incentives to build data centers there. So the connectivity from tier 1 markets, where a lot of the eyeballs are, and the users accessing your mobile devices or sat at a desk using those services, to those kind of cheaper operating centers, I think is a swing that we'll see over the next, you know, handful of years. It's already there, it's already starting, so that connectivity, that's going to drive more fiber builds out into those areas. So I think, you know, the cloud services has been very tier 1 focused over the course of the last 2-3 years, because that's where the major data centers have been. So we see that swing going on as well, and again, it just comes back to solutions. Any one application of the cloud is so different for a particular enterprise customer. How they do that, part internet access, part dedicated access, DR goes into it. So trying to look at it through your customer's lens, I think, is the key.
Right. I was going to maybe ask you, Tim, to talk a little bit about the data center piece, because you know, as David was saying, that's really kind of the issue. Building or having those data centers in places like Atlanta, like tier 1 cities.
Yes, ma'am. The data centers are there, and most of the times they have the infrastructure. You know, we'll just say the cloud part of that. Big part of why people are going to the cloud, they're only utilizing 10% And that's how can I make money on the other 90? Data centers are that way too. Nobody builds like 1,000 square feet and fills up 1,000. They say, well, I hope somebody else is going to come, I'll build some more. They always have a glut. I know for me, I have probably 30 to 40% of additional infrastructure and space ready to take on the new services. And what I think about cloud, I think we all can agree upon, is the technology of the cloud and the apps and everything that's going to happen is just going to be a large demand. And then I think we come back to the crux of the issue, which is supply, which is all my colleagues here do that. There's going to be a high demand, but there's not a lot of supply. So I'm real happy on these initiatives, we'll cliche that word, is we got the facilities and the structures to have the capability to do all these apps, but we need the bandwidth, we need the fiber, we need all of it to be able to come in. And I'd like to go off what David said. Also, a lot of folks don't understand on the cloud, if you push all these services to one data center, we'll say such as mine, everybody wants a backup. So now we just doubled what we need by putting it on another offsite, and we got to, we'll say, backhaul it or get it over to there. Right. So I feel very fortunate, and I love, like I said, the cloud could be a diversified term that people will call it, but for us, the infrastructure is not going to change in the data centers. I mean, basically, and I like what David said, those people that love to hug the box, we love those people in my world. So yeah, we love to have them come in and hug the box all day long in my room. And whether it's the hugger being the user, or it could be the huggio, I guess I'll call it, the cloud provider, the data centers support both. So I really think the infrastructure is great. I just see the demand really going up because the cloud's an exciting, new, innovative. Now we've got the IEEE talking about it, which, I'm an electrical engineer. I hadn't heard IEEE in 10 years. I thought they went away. So they've raised their head again, and to no avail, actually. And I agree with David. I hope nobody's in here with the IEEE. I lost my charter membership. But no, I think all the data centers, similar to mine, which all we are is really it's an interconnect, and in my room I'm neutral, so I offer no services. And there's quite a few companies like mine that are ready for the cloud, they're ready for people, and they're ready for this infrastructure to come.
That's an interesting point, actually. A lot of the data center operators are turning into cloud providers, right? Looking for other revenue streams. Right. They've got their customer base in there. They've sold space, power, interconnects, and now moving into cloud services, cloud providing. That's interesting how that will work out just for some of those companies, and whether the end user wants to buy a total end package solution with all of those pieces together. I'm not so sure everyone will.
Yeah, I'd agree with that. I wanted to bring up a point about something that Tim had just mentioned. Relative to fiber infrastructure building, and then folks that lease or IRU dark and light it, and but about the cloud, and it's really the distributed cloud. And I talk a lot about distributed cloud. Some people talk about distributed cloud computing. They'll add the word computing. It's a little bit different. What happens is a function within the server of CPU processing. Servers connected via a network, and then the whole thing combined is the cloud. But what's really happening, and if you look at mobility and you look at LTE, and people talk about spectrum and spectral efficiency, and the constraints that mobile networks are now having because of all these apps and workforce and enterprise and everything else, what has to happen is that the server clusters need to be distributed physically, because you can't have them just centrally located in major cities, because then it creates this issue where sessions need to be established across great distances. And the network then is strained tremendously, particularly with video. So when you introduce video and you're trying to establish sessions from a mobile device to a source of content, let's just call it YouTube or Hulu or whatever, the greater the distance that has to travel, the more capacity it takes up, the more sessions, and then it overloads the network. So distributed cloud computing, and you could think of it as sort of micro cells in the way that they're trying to talk about small cells for cell sites. It's basically a container or a modular data center business that houses servers that gets physically distributed in different places. These are smaller sites. They aren't the monstrosity million square footers. They are in search of cheap power. They need dark fiber to plug into. So we fashion ourselves as a sort of giant Lego pad, and you can take this little thing and just plug it in where you need to, which is great. And enterprises have needs, and hospitals, and HIPAA compliance, and SOX compliance, and video for mobile, and they can all be scattered about. But what's interesting is that none of that is actually going to detract from what Tim does in the major markets. As a matter of fact, Tim's boat will rise with the rise of the distributed cloud tide as well, because those are all points that are being completely unserved presently. They're all being stressed by network that essentially doesn't exist, whether it's in the spectrum, which all the mobile operators will say we need more. That's because they don't want to address the fact that there isn't fiber enough so at all the towers. If it were there, then you'd still have the issue of the long distance that everything would have to travel to establish the session. So it's sort of like peering. Peering is local. IP networks want to peer. They want to keep traffic local and basically offload as soon as they can. So there need to be more peering points. And these are not just physical and transport layer peering points. These are application layer peering points. And there will be many, many, many of them. But it doesn't detract from the sort of central nervous system, the core neural points like a New York or an Ashburn or Atlanta or Chicago, that all of those little local networks and local clusters will all feed into as well. So a lot of folks think of it sort of as one is opposed to the other, or detracts from the other, or takes away from the other, and that's not the case at all.